Hello, everyone. Good morning, good afternoon, and good evening to you all. Thank you for joining our current KX webinar, where we will be diving into KDB-X and learning all things about building, analyzing, and innovating with KDB-X, the next generation of KDB+. My name is Ryan Sigler. I lead our developer relations team here at KX, and we're really happy to be joined by the product team here at KX, led by Manish Devgan. Also, we have Connor Gergin, who is our principal product manager here. And then we have Aldred Coetzee as well, who is a principal product manager as well, who will be walking us through several awesome things about KDB-X. Now, before we get kicked off, a couple of housekeeping items here. Number one, I know the big question. Yes, this is being recorded and will be available after the session ends on YouTube and on LinkedIn. And finally, we also have a way for you to ask your questions during this session. If you go over to the comments pane, you can put your questions and comments there. And at the end of the session, we'll have a few minutes where we can answer all of your questions about KDB-X. So with that, let's look at what our agenda is today. First up, we'll have a timeline of the reinvention, talking about where KDB-X came from and how it came to be. Next, we'll talk about some of the cool features of KDB-X that empower developers, which we're going to take a quick look at the KDB-X modules, as well as diving deeper there into the road to the lakehouse and how KDB-X supports open data formats. We then take a look at the MCP server for KDB-X, and we'll have a great live demo from Aldred on that. And finally, we'll end off with a look into the future, where Manish will talk about the upcoming roadmap. And then again, if you have any questions, we ask you to go ahead and put those in the chat, and we'll get to those at the end of the session. All right, so with that, Manish, go ahead and take it over.
Thank you, Ryan. Welcome, everyone. Today, I'll be taking you through a bit of a story, our origin story of KX products, and how we are continually reinvented ourselves to meet the demands of real-time data, advanced unified analytics, and now AI-driven workloads. My section will cover where we started and what we have built, and how KDB-X represents the next major leap forward for KDB and the ecosystem. So let's dive in. If you go to the next slide, this slide illustrates the three major eras. The first one is the foundational era, which began in the early to mid 1900s and 1990s, where Arthur, one of the pioneers of array programming, created the language K, drawing inspiration from earlier languages. And in 1998, he released the first version of KDB, which was a radical thinking on how time series data should be stored and processed. KDB introduced a columnar in-memory architecture and vector-based execution model that allowed entire arrays of data to be processed simultaneously rather than row by row. That design was decades ahead of its time. Then came the specialized era, which began in around 2003, where KX introduced KDB+, along with the Q language. Q made the power of vector programming far more accessible, where KDB+ expanded the underlying engine to 64-bit computing. This combination quickly became the de facto standard across global capital markets. So from trading firms to risk systems and surveillance platforms adopted KDB+ because it was the only technology capable of ingesting and querying massive volumes of high-frequency data in microseconds. So for nearly 2 decades, KDB+ has been the backbone of some of the most demanding real-time systems in the world. And now we enter the AI native era, represented here by KDB-X. KDB-X builds on the proven foundation of KDB+, but extends it to meet the needs of real-time AI and modern data ecosystems. With KDB-X, we unify streaming, historical, and vector search in one platform. We support open platforms like Parquet. We integrate natively with Python, and we add multimodal AI capabilities and GPU acceleration, all while preserving the performance and consistency that have defined KX for decades. So when we talk about KDB-X, we are not talking about a new product in isolation. We are talking about the next reinvention of a tech lineage that started about 30 years ago, one that is powered by the world's most advanced real-time systems. If you go to the next slide, this slide captures the core challenges our customers face today as they push towards real-time decisioning and AI accuracy. First, siloed solutions stall progress. And as we see, most organizations stitch together separate systems for streaming, analytics, storage, and AI. And every time data crosses a system boundary like that, they lose speed, context, and reliability. Second is the latency bottlenecks. Whether it's market data or sensor data, the architecture itself often slows things down, turning what should be a millisecond decision into seconds or worse. Third, the AI ambitions run into integration roadblocks. Teams want to apply AI on live data, but their model sit in one place, their data in another, and their pipelines aren't built for continuous inferencing. And lastly, we see data overload versus decision advantage. Firms have more data than ever, but very little of it is actionable in the moment. Together, these pressures are why speed and accuracy matter so much, and why KDB-X is designed to collapse these silos, eliminate latency, enable AI on live data, and turn data overload into real-time decision advantage. In the next slide, if we look at the vision behind KDB-X, at the core is the programmable runtime based on Q. Python integration, persistent tables, and recently released module system, which Connor is going to talk about. Above that, we plan to have DB services that provide abstracted, efficient access to real-time data and historical data stores. Connect would manage all sources and sinks, including the next generation of feed handlers, which we'll build on top. And over that, we have dashboards, which include our new interfaces on the roadmap that will provide a natural language experience for both dashboard building and viewing. And finally, AI plugins and integration will include GPU acceleration that comes early next year. These layers will form a single unified platform, which is designed for real-time AI. If you go to the next slide, this is one of the most important charts in my set of slides because it explains the true differentiator of KDB-X, which is a programming model powered by Q. Let me start with the first pillar, the one programming model for all real-time data. This is where Q is fundamentally different from time series databases, vector databases, or general purpose cloud data platforms. Q is an array-based vector programming language tightly fused with KDB plus engine. It's designed specifically for time series and event-driven workloads, and it operates directly on the entire vectors of data in memory. That means complex operations like windowing, joins, transforms, or analytics in general can run in microseconds on billions of records. Instead of one system for streaming, one for SQL, one for vector search, KDB-X gives you one unified model. The second core pillar is the modular composable system. The new module framework we recently released as part of Gergin brings modern software architecture into Q. Modules give you namespace isolation and encapsulation, and in the future, we plan on versioning and dependency management. This turns KDB-X Q into a genuinely modern application platform where developers can assemble applications using official modules, and Connor will cover what we have delivered as part of KX module, and also open source module like regex and logging. This structure makes Q not just a language, but a fully extensible ecosystem to build on. And the third pillar is the integration with Python, SQL, and external systems. So even though Q is a high-performance core, developers can use the tools and languages they already know. For example, Python, SQL for querying, and REST for services, and connectors for cloud storage or enterprise systems. KDB-X becomes the programmable real-time engine inside the broader polyglot environment. So finally, the takeaway from this slide is that KDB-X is not just a database, but also a programmable app enablement engine. With that, I will now hand over to Connor to talk about some of the amazing capabilities we have delivered as part of our GA release. Over to you, Connor.
Thank you, Manish. Okay, I'll take it from here. So I just want to kick off by reiterating that KDB-X is built on the proven foundation of KDB and Q. And this release really represents a major step forward for all KDB developers, new and existing. And over the past year, KDB-X has been shaped by the community. So through extensive collaboration with users and their engineering teams, the experience has really been designed to make it much easier to adopt, extend, and simply use KDB. So one quick example, the installation for new users is now completely pain-free, right? You can get started in seconds, get a new machine running with the Community Edition with one command. And for the agenda today, I will first set the scene on KDB-X modules. These are significant improvements to how teams compose and manage scripts and utilities in Q. And these enhancements really have set the groundwork for the next phase, one of which is Parquet and our new open format capabilities, which reduce barriers to entry for new users and offer greater flexibility for any data handling. Aldred is then going to take us through some of the AI innovation coming with KDB-X. So next slide, please, Ryan. Okay, so empowering developers. The Q ecosystem today is immensely powerful. And on the other hand, you can make the case that it's fragmented. So it's pretty difficult to collaborate and reuse libraries today. Things are on GitHub. We ourselves have released things, but it's not centralized. So with KDB-X, we have some work to do. And what we want to do is really set out to create clear standards and tooling for library development with the goal to enhance Q's loading and namespace system whilst we're doing that. And to do this, we really need to change the language itself by introducing innovation and primitives to make building, using, trusting Q libraries much easier and safer. And next slide, please, Ryan. So what we've done is introduce what is called a module, and modules simply unified namespace and library concepts. So if you think of a module as a unit of code loading, we've now got Q primitives to modernize how libraries are handled. And you can think of this as similar to Python style imports. So your import pandas as PD is essentially something that you can do now with KDB-X. So there's standard practices for module creation as well, which we have documented. And fundamentally, this is introducing aliasing. So you introduce safety by removing the chance for namespace caches, which allows you to keep all variables and functions self-contained, so modules aren't interfering with one another. And that gives you the ability to move modules around, whether that's on the file system or in memory, without breaking references. Next slide, please, Ryan. So at our GA KDB-X launch, we also released quite a few new modules for users. Some of those you'll recognize from the Insights core family, but others are net new. So Parquet and AI libraries are now included as part of the reference library during installation. And going forward, we will continue to release open source modules to GitHub. These modules are similar to the Fusion family that we've released in the interop space. They will extend core KDB functionality with things like machine learning, regex support, improved logging, and lots more. So you can use these as strong examples of how to build modules or simply use them as they are. And we obviously hope that these will help you to increase productivity and collaboration within the wider community. Next slide, please, Ryan. So yeah, at launch and in recent weeks, we've also seen the community and partners begin to contribute to the module ecosystem, which is fantastic. And we've worked closely with partners like Data Intellect and Version 1 to seed high quality modules and including blogs on these new features for the community. We're definitely expecting to see lots more open source modules published, both from ourselves and the wider community. And initially we're hosting these on GitHub, but we do have plans to have a much more permanent home for these modules in the future, which Manish will talk to in his roadmap section. Next slide, Ryan. Okay, so that's great. Modules are interesting, but what modules have you released? So the road to Lakehouse, as you can imagine, we've been talking a lot about open formats. Our customers have been telling us consistently the same thing. That is, they love the power and performance of KDB, but they would love to have that experience and integration more naturally with open ecosystems, especially those that their teams already use. So some of the big themes that we've seen, obviously Lakehouse in the cloud is becoming the standard for cloud teams, but generally data in open formats is something that our teams, even on-prem, want to onboard quicker. So they want more interoperability with other engines as well as Q, and they want the powers of Q without having to go through deep format conversion, which is intensive both from a infrastructure and a human perspective. So what we're announcing as part of KDB-X is the support for open formats. Ryan, if you could go to the next slide. So this really couldn't be simpler to understand. If you can run QSQL on a HDB, historical database, you can now run QSQL on a database of Parquet. And Parquet is really a critical foundation towards integrating with Lakehouse. So under the hood, Iceberg is just Parquet with some extra metadata. By integrating with Parquet, that really opens us to the future Iceberg integration. And yeah, the integration itself, without having to go through deep backfill exercises to start to work with new data sets, you can simply start using Q directly on that. And I'm going to show a demo on this in a moment. The benefits are obviously that new teams can start to tap into rich data sets that they have with Q. They get the power of Q in new architectures without having deep expertise, and generally lower friction, better adoption, and greater time to value is something that everyone will benefit from. Some of the initial use cases that we are starting to see for this, so obviously data science and anything exploratory with Parquet. So that could be looking at new data sets. It could be just kind of your last mile style analytics where you're querying, and there's maybe not a super high performance need. Also ETL and converting Parquet, we don't expect that to stop. People will still want to move data into the native KDB format, but the kind of North Star for this integration is really how we'll merge these two. So how do I have a historical database tiered with recent data in the native higher performant format and older data in Parquet? So Brian, if you could jump to the next slide, I'm going to show a quick example of some of the support we added. So partition virtual tables. A virtual table is really something that looks like a KDB database, but is ultimately comprised of open formats, in this case, Parquet. So what we've done at GA is we've added support for virtual tables, which you can think of as similar to a date column in a HDB. So in my example here, I have some Hive partition data that is essentially a key value pair where I have exchange and I have date. And you can see when I run a query, which is QSQL, I compute the volume weighted average price by symbol, and I'm filtering then on date and exchange, which are not in the data set, but inherited from the folder structure. So that's important because it allows us to skip all of the data that we don't care for and ultimately target the data we do. And you get the full flexibility of the QSQL engine here, including MapReduce. So next slide, please, Ryan. In the demo that I'm about to go through, let me just set the scene. So effectively, you've now learned that KDB-X supports open formats, initially Parquet. And you know this is going to open the door to exploring more data sets. That could be from a vendor, that could be from an internal system. But ultimately, you don't want to convert that data, right? So in this demo, I'm going to be working with Nextly, from which we've converted CSV to Parquet. And the first goal is going to be to load it, right? Without converting the data, right? This isn't some backfill exercise that we do to get it to work. This is, I have Parquet data that came from some other system and I can just use it. I can start to explore it. I can start developing queries. You can obviously look at its structure, its contents, and determine its potential value. So once that data is loaded, you can then also look at performance. And we're going to provide some tools in this demo that show you how you can compare Parquet versus our own format. And then I think in the future, we'll probably release some utilities and repositories to help you do this yourself with your own data and your own queries. So by the end of this demo, you should hopefully understand at least if the data set is a good fit and if you want to adopt KDB-X. So I am now going to take control of the screen and go through a demo. Cool. Okay, so here I am in my Jupyter Notebook, and I'm first going to import Parquet-X. And Parquet-X is using the Community Edition license. And I'm going to enable the queue first mode. So now every cell that I run going forward will be queue only. I am going to start by loading some utilities, which will help me in my benchmarking. They simply profile the functions and add the execution times and query to a table. Next is the first look at the Parquet module. So what we're doing here is we've introduced a new keyword use, which allows you to effectively import modules. And importantly, that gives you the ability to create your own variables, right? So all of the APIs returned by this public interface, the Parquet public interface, I can choose to store in whatever variable I wish, which is a key difference from traditional libraries. So I've imported that, and next I want to look at some Parquet data. So in my example, I have some uncompressed Parquet. You can see there is quote and trade, and it is partitioned by date and symbol. In this case, I have one Parquet file per symbol. In this demo, I am going to have two utility functions. Simply think of these as a way to parse the directory structure and then a way to inherit that into a table. A very quick example, load hive table parses the file name and gives me two columns, date and symbol. That is what we will use for the virtual table. And load hive dataset just simply parses those structures and creates the table. So I now have quote and trade. These are partitioned Parquet virtual tables. They are type 112H. They are not type 98H like traditional KDB partition tables. I can seamlessly interact with that data. So in this case, I'm doing meta on the quote table. You can see the data types that KDB-X has parsed those into. And ultimately, I can kick off the interesting part now. So I have some tables. I now need to get the tickers that I'm interested in. So I get the top symbols sorted by the number of quotes. I get a high frequency ticker at the 80th percentile, and then I get the top 50. And this will essentially give me everything I need to run the benchmark. So what you see below is one simple function that we have that runs a lot of queries. You can see there's some queries here that do simple selects. There's some simple select and aggregates. There's something similar to a volume profile. There's calculating midpoint average, volume weighted average price, bid and offer. Yeah, there's lots of use cases here, lots of potential. This could be anything from simple reporting on TCA to calculating order imbalance. So that function I'm going to just define, and then I'm going to execute. So now all of my queries above are running against the Parquet data. This isn't an enormous data set. It's a couple 100 million rows. I execute this, and in just a second, I'm going to calculate the average. So that will complete in just a second. And here you can see the results. So here are the queries. This is just a table. And on the right-hand side, you'll see Parquet average. So some of these queries take over 3 seconds. I think this one is pulling quite a lot of data, so that's okay. And others are in the range of 80 to 70 milliseconds. So next, I'm going to jump to the KDB database. And this is something I had pre-created. And it is, again, the nicey tac data. So I load that. I then check the type. You can see it's 98H, which is a partition split table. I do the same exercise of running all of the queries. Again, these are identical queries to what I ran with Parquet. And similarly, I'm going to select the results and store those. So that's completed. Again, to the right-hand side, I have my average query times. And finally, I'm going to do a very quick comparison. And you can see in this example, the KDB format was on average 4.6 times faster. So again, must stress, this is just an example. Your mileage will absolutely vary with your own Parquet data and queries and obviously hardware. But I thought this was a great example of what we've done in KDB-X. And obviously next up, we're going to release some benchmarking utilities to help you understand whether or not Parquet is a fit, including other comparisons with engines that support Parquet and obviously best practices. So thank you everyone for your time. I'm going to hand over to Aldred.
Hi, everybody. Thank you so much for your time today. I'm going to give you a whirlwind tour of what we've been doing to enable agentic AI integration with our product stack on top of KDB-X. I'm specifically going to look at the KDB-X MCP server, how it integrates with KDB-X itself, and usage of the AI module. Go to the next slide, please, Ryan. Okay, so as a kickoff, let's just talk about what our MCP server brings. It's publicly available, it's open source, you can download it, you can encourage to clone it, you can contribute back to it, and we'd love to get people contributing back to it. It's built with the mindset, it's built by builders for builders. You can use it as is, but what we're really hoping you'll do is you'll take it, grow it, use the templates we provided, and make it fit for your own plant. It has the standard things you'd expect an MCP server to have that connects to a data store of sorts. It takes care of all your boilerplate concerns, your connection and session management. It checks if licenses are there. It checks if if your tools are running correctly. It captures those errors, logs those, etc., etc. We've also shipped with some out-of-the-box working tools, resources, and prompts, which, although simple, are actually pretty powerful. So we've given you a prompt that you can use to dive into a particular table and analyze it in different ways. We've given you both static and dynamic resources. A dynamic resource which will allow you to see what databases and tables you have available to you, and that will update as it runs. And then we've got some static guidance so that when the LLM tries to create SQL to run against your tables, it does so in the best possible way to limit the impact on your KDB plant. Tools, we provided some simple yet powerful tools, which we're hoping will provide the basis on which you can grow. So something like a run SQL query tool allows the LLM to run SQL against KDB. A similarity search, which leverages the AI library tool to run to do your RAG and run some searches there, and a hybrid search tool, which allows you to run searches against tables which have both dense and sparse embeddings. The main thing, though, that I want to focus on is the builder side of it and have a look at some of the templates that we provided, in particular the tools template. You hop over to the next slide, please, Ryan. Cool. So what we've done, what's shown on the left of the screen, it's a bit small, but you'll get the link to it after this, is the source of the MCP server that you'll get when you download it. And what you're seeing there is a templates file for Python. The idea is that you'll take that, you'll copy it, name it to whatever you want for your particular tool, and you'll use that as a template to build your tool out. And the reason we're providing these templates is that we're very much aware that people take KDB and they build what they want with it. Your data, typically massive data sets of billions and trillions of rows, isn't typical to somebody else's, isn't the same as somebody else's. And so what you build and how you build it is entirely up to you. There are two parts to this template. The first part is the implementation template, which is the top one. The second one is the one which allows you to register your tools and to describe the doc strings. The one key thing to keep in mind with the MCP servers and the LLM interaction is that your doc string is all it really knows about. So it's really important you get that straight. And we've got similar templates for resources and prompts. Next slide, please. So just an overview of how this fits in, because sometimes it's easy to forget. This slide is a combination of two things. It's showing where the MCP server fits in a typical flow and just in general. And then I've taken an example type flow from a user prompt through to how it interacts with KDB-X and back. So important thing to bear in mind with MCP is that MCP, you need both an MCP client, whether that be an app or an agent, and you need an MCP server. And what's important here is MCP defines the protocol, which allows those two things to communicate. What happens initially when your MCP client starts up? You'll have configured your MCP service that you wanted to know about. It will look at that configuration, check with the MCP servers, and it will load up all the tools, resources, prompts that are available from those MCP servers. And then it's ready to go. And then people can connect to it and use your MCP application. So if we have an example where a user asks, summarize my current portfolio positions, the LLM will be the one that knows about the primitives that are exposed. In our case, with this example, the KDB-X describe tables, dynamic resource, the SQL query guidance, static resource, and the run SQL query. The LLM will interpret the intent from the prompt. It will plan out what it needs to do, and it will decide which MCP primitives to use. And at that stage, it will then make one or more calls to the MCP server to use the resources and tools that are exposed. So a flow for this might look like, let me go and call the KDB-X describe tables resource, find out what tables I've got, that data returns, and it says, right, I'm going to query those tables in order to run SQL queries. Let me get some guidance first, so I'll make a call. SQL query guidance is a static resource, and in our case, it's a file saved within the MCP service that doesn't have to interact with KDB-X. And then it will run multiple calls to the KDB-X run SQL query tool, which will then, the first and last calls will end up running Q code against KDB-X. Once all the data comes back and the LLM believes it's got enough data, it will consolidate it and return it back out for further processing. Important thing to bear in mind with MCP servers, particularly our one, so you could do it differently, I guess, but with ours, there is no AI involved in the MCP server. What gets run on KDB-X is Q. All the model configuration and that side of things sits at the LLM interaction user query layer, which is with your MCP client, whether that be app or agent. Cool. That's it from there. We can go to the next slide, please. Right, so what I'm going to show you is as quickly as I can, because we are limited with how much we can pack into a demo. I'm going to show you a demo of a CRM system. It's tiny in data, all the data is synthetic, and it's been put together for demo purposes. And I'm going to show you a kind of workflow where we've got a client that's having difficulties, kind of in a perfect storm state. You want to drill into that as an analyst or somebody who's on the sales desk. You find out all the detail, you've got all your evidence, you then need to present to management, and then after that you might want to also have a look at how your portfolio is doing overall. I'm going to share my screen and show you that. All right, so before we jump into the actual demo, I thought it might be useful to show you the components that we're using in the demo. Obviously our data store is KDB-X. And you can see here we're using KDB-X5, and we're using the community edition, which has a non-expiring license. I've loaded up a very small data set of trade data, about 600,000 rows of trade data and 1,000 CRM-related documents. And that documentation varies from call transcripts to emails to filings to news articles. You may have different kinds of data in your org, but just to give you an idea and a feel for what I've stored there. You can also, if you look at the meta on the CRM docs table, you can see that we've got a sentiment score that we've added when we brought our data in, and we've also got the dense embeddings added in, which will allow us to perform a similarity search against the data. I've also just shown that the AI module is loaded. For this particular set of tooling, we're going to use the flat search to perform our similarity search when we retrieve our CRM docs. I also have the MCP server running. You can see that's running and exposing port 3002. At startup, it does several checks. It checks to see if KDB-X is there, and then whether the SQL and AI modules are loaded, which they are. And then it proceeds to load up your tools, prompts, and resources and register them. And then at that stage, it then waits for connections. And you can see near the bottom that a connection was made, sessions were established, and a requests were issued to list the tools, prompts, and resources that this particular MCP server supported. The client that we've used for this is the Claude desktop. I've used that because Claude, or Anthropic, went in and they published the MCP documentation back in November 2024, and their client showcases support for prompts, resources, and tools. A quick overview. If I look at what's available in KDB-X, here you can see all the prompts and the resources that are available. For our demo today, we're going to use the Search CRM data prompt for one of them, and we're going to use the SQL query guidance resource when we run our SQL queries. From a tools perspective, I've only got two tools enabled that we need. The Run SQL Query tool, which will take a SQL query and then run that against KDB and Qcode. And then we've got the Search CRM docs, which under the hood uses the AI Libs functionality to perform a similarity search on our CRM docs table. Right, so let's imagine we're working on a sales desk. We know we've got a particular client that has a problem, and we want to get as much detail as we can before reporting up to management. We might use a prompt something like this. Where the prompt is. We might use a prompt that is something like a search CRM data prompt. The user will then fill in a client name. In our case, I think we used tech management, an analysis type, perfect storm, for example, a focus area, which might be relationship health, and an analysis depth. It might be comprehensive or focused or something like that. In this particular prompt, we've gone to Tech Corp Holdings as the company. The prompt that's been generated says Tech Corp Holdings Management. We've gone for a perfect storm with a focus on relationship health, and we've asked for generate a comprehensive report. What's inside this prompt will change depending upon which values you choose. The LLM then goes and orchestrates all of this, decides on an approach, so it knows it needs SQL guidance, it knows it needs to run SQL queries, it knows it needs to search CRM docs, and then create a downloadable report. So it plans the tasks, orchestrates them, and then runs a whole bunch of steps. So it gets the SQL query guidance, runs the SQL queries, runs some similarity searches on the CRM docs, and it's the LLM that decides when it's got enough data and what queries to run, and it creates the queries both for the SQL and for the CRM docs. Once that's run, a report is generated, and the report is generated as per the guidelines in the prompt. I'm not going to run through this whole report because it's a pretty meaty report. But yes, we do have a client that is close to churning. The report has validated that. And if we scroll through it, you can see down the bottom in the appendices here is we can get a look at all the SQL queries that the LLM generated to support its assumptions and conclusions. You can see the formulae that it actually used to calculate the different trends that it spotted. You can see what documentation was used to support its CRM sentiment analysis. And then down here, you get some validation that it just sanity checks the data to see if it makes sense. That report is really big, and chances are that once you've done your research, you don't actually want to show that to everybody unless you really need to. So when you're reporting up and discussing with your colleagues to decide your next course of action, you might want that report to be summarized. This is a very simple ad hoc prompt which asks for a summary of that. This works because we've got that report available to summarize. And here you can see that a report is generated, which at a glance shows you what the problem is, the revenue that's at risk, the probability of a churn, the expected loss, and the reason for it. We've got a volume collapse, we've got the commission rates just gone up and up, the execution quality's dropped off, the sentiment's terrible, and got worse, the competition, they're looking for somebody else actively. They've escalated to the board, and the communication is getting more and more negative. And lastly, I want to show you something to do with more like an ad hoc type report, which of course you could change into a prompt if you wanted to. But in this way, I've kept it ad hoc, and it's a report across your portfolio. So you want the context of this, and so I've just let ad hoc conversations continue, and at the end of it, asked for a report summarizing the state of the portfolio. And what you can see in here is you end up with a summary as expected. Tech Corp's at the top. It's got the biggest problem. It's a huge chunk of our revenue, etc., etc. But we've also got at-risk and declining clients, which may not be worth as much money to us, but they're still important. Then we've got our stable ones. And at the bottom down here, we've got a watch list of ones where everything seems okay, but the volumes are dropping. So it also looks at other things like our revenue concentration issue across our portfolio, our average execution quality is pretty low and dropping, and our portfolio sentiment is just about positive. Summarizes actions that could be taken in P0, P1, and P2, and looks at cross-sell opportunities. I hope that this has given you a feel for what is possible. In this, we've only used two tools and one prompt overall in all three things that I've shown you. But hopefully it has given you a taste to work with your KDB-X data, whether it be structured, unstructured, and bring those two streams together. Back to you, Ryan.
Manish, we could take a quick look ahead at the roadmap there.
Sure, Ryan, and thank you for to all the attendees for their time so far. And I wanted to briefly walk through the roadmap. It's important to note that everything you will see is forward-looking and based on ongoing work, research, and customer feedback. KX and our product team is committed to being open and transparent about our roadmap, and we publish updates through the Developer Center. So actually, if you go to the Developer Center today, you will be able to see the roadmap which we are planning towards. We love your feedback and co-innovation, so please reach out to me and my product team if you have any input for us. With that, I wanted to go to the next slide and walk you through the roadmap exactly as this slide lays it out. So from left to right is the timeline, and then from the top to the bottom on the left are the various themes we are planning towards. So starting with the top row, which is extensibility, this is one of the biggest and the most strategic investment area for us. So as you heard from Connor, that when we released KDB-X GA, we introduced a new module system, which forms the foundation of application composability in KDB-X. In the next 6-month window, we plan to expand this with versioning and dependency management. So essentially package management capabilities that users have been asking for in our preview cycle. And so you can think of this as early steps towards a PIP for KDB, which will enable teams to package, share, and reuse modules in a standard way. And in the second half of next calendar year, in that horizon, as we get feedback along the way, we plan to launch an official module repository or a registry, and this will become a central place for discovering and publishing and basically looking at all the community-driven ecosystem growth around modules. The second row is about interoperability. And as you heard in GA, we already support Parquet, SQL, and Python as first-class APIs. And in the next 6 months or so, we plan to expand Parquet capabilities with deeper object storage integration and enhancements to the virtual table system Connor talked about. And this virtual table system is the underlying capability that makes Parquet support possible today. And it'll be extended to support additional open formats. And by the second half of next year phase, we plan to introduce support for broader open table formats, including iceberg style layouts and further lakehouse integration, giving our users more flexibility in how the data is stored, partitioned, and accessed across all these distributed environments. And the third big theme for us is accessibility and developer experience, which is all about making KDB-X easier to adopt and more enjoyable to develop with. And with GA, as you all heard, we released the community edition, which makes KDB-X freely available for personal and commercial use, and it dramatically lowers the barrier to entry. And in the next 6 months, we are focused on releasing new developer tools, things like better and improved debugging and enhanced logging. And around the second half of next year timeframe, those tools become more advanced and integrated, including built-in support for linting, better profiling, and overall improved and a modern development workflow in KDB-X. Finally, at the bottom of the slide, we have the theme around data and AI services, which is where KDB-X becomes truly democratized and AI native. At GA, as you heard from Aldred, that we delivered the integrated AI libraries as a module and also made available an MCP server, which we have shipped as part of the preview. We also plan to ship a preview of what we are right now calling a vector DB service, which will be the foundation for multimodal and retrieval augmented workloads. Within the next 6 months or so, we plan to introduce and release GPU accelerated KDB-X and a preview of a full DB services layer. This DB services, which will abstract storage, query routing, and historical and real-time access under a consistent service. And the second half of next year, in that horizon, we plan to bring DB services to general availability, making KDB-X a unified and a production-grade platform for time series, vector search, streaming, and AI workloads. So when we put this all together across extensibility, interoperability, DevX, and data and AI services teams, what you see is a roadmap which is entirely driven directly by user feedback and also designed to strengthen the ecosystem open up the platform and also modernize development on top of KDB-X and push performance even further. It is our long-term commitment to building not just a faster database, but a more complete, unified, real-time data and AI platform. So that's our roadmap. I'll hand over to Ryan from here.
And now I'll bring everyone back up on the stage here for a few questions from the community. One that we had was, how different is the Q language in the current version KDB-X versus the old version KDB+? And is it similar to the differences between C++ 23 and C++ 98? Maybe Manish or Connor, would you like to field that one?
Yeah, sure. I can take that. So one thing when we developed KDB-X, we made sure that it's fully compatible with KDB+, 4X versions and beyond, which basically means that the code bases that run on KDB+ 4X will continue to run on KDB-X without any changes. So where KDB-X differs is not in the language per se, but the brand new capabilities which we have added on top of the language, which weren't possible in the previous versions. And one of the examples which was highlighted in this webinar was around this whole module management system, which basically extends the language capabilities through these packages and modules, which are built on top of that platform. So those capabilities simply did not exist in KDB+ 4X, but your Q code in those versions will continue to work as is in KDB-X. Connor, you want to add anything to what I said?
No, I think that's spot on. I think the example given there, C++ 23 to 98, introduced a lot of breaking changes. We certainly haven't done that in KDB-X.
All right, thanks, Connor and Manish. And one other one from the community here. Are there any plans to allow the user to read Parquet strings as symbols? Maybe one for you, Connor.
Yeah, sure. And hello, Owen. Yeah, so we don't yet support converting from Parquet strings to symbols, KDB symbols with the Parquet module, but the plan is to add this. And yeah, along with that, we're going to be making a bunch of changes to how KDB manages the internal symbol table, especially around concurrency, which will be important for Parquet. So yeah, that's coming.
Awesome. Thanks, Connor, for that. And thank you all for joining. If you have any other questions, a great place that you can ask those is in our Slack community. You can join that at kx.com/Slack. It's probably the quickest way to get a hold of us. Or if you have specific questions for the speakers, you can find their contact information right here on the slide. Now, we went through all sorts of awesome capabilities today and talking about KDB-X, and you are able to try that out for yourself with the KDB-X Community Edition, which is totally free for you to use. There's no expiry date, and it's really a great resource. And if you want to give that a try, you can go ahead and go over to the Developer Center by scanning this QR code there, and you can get signed up and get KDB-X downloaded and get up and moving on some of the stuff that we even showed in this session just in a matter of minutes. So we try to make it very frictionless for you to get started. And with that, I want to thank you all. And thanks to Manish, Connor, and Aldred for the awesome presentations and the demos. We really appreciate that. And of course, thank you all for joining. We appreciate your time, taking a little time out of your day to learn a bit more about KDB-X. So thank you all, and we will see you all next time. Have a great rest of your day. Bye-bye.